Okay, I think we're just about to get set up. So every year I give a similar talk, and this year I always want to build a theme to it. And to this year, I want to build a theme about building a thriving community within SYCL. All right, so we can get started. So my name's Michael Wong. So welcome to everyone viewing this and here, as well as in the future on the internet. It's been quite a few years since we've gotten together. As Simon said, it's great, isn't it, to finally see people face to face at last. I've been getting tired of talking into a video camera for the last couple of years. All right. So there's three things I want to talk about this year. One is, of course, about SYCL's insanely amazing growth in momentum from 2016 to today. And then the second thing is I want to highlight the significant accomplishments that we've had in the last 12 months since the last SYCLCON 2022, IWOCL. And it wouldn't be a keynote if we don't talk about SYCL future directions and the ecosystem. So let's dive into it. So I opened last year with this about the idea that programming models must persist. It's one of the things I learned over 20 years, 30 years now in high performance computing, previously with OpenMP. This year, I want to add the idea that programming models should also have to have high quality, portable implementations. And the way to ensure that is to have conformance tests. So that started making me wondering how many programming models actually have standardized conformance tests. And it turns out there aren't that many. I know all the base ISO languages like C, C++, none of them actually have official conformance tests. I mean, sure, they have vendor commercial tests that you can buy and test your compiler and so forth. I looked around, it turns out that ECMAScript, HTTP, Kubernetes actually have conformance tests. And maybe you guys know more that I've missed. But what's astounding is that almost all Kronos language have a standardized conformance. Now, this is important. The latest version of SYCL is SYCL 2020. Which was launched in February 2021, bringing obviously, a new level of expressiveness, we think, and simplicity for developers who wish to program heterogeneous parallel processors using modern C++. Now, if your company is developing a product that implements a Kronos API standard, then it has to pass conformance tests as defined by Kronos before you can use the name or logo of the standard in association with your product or call your product compliant or conformant with that Kronos specification. Now, what this does is that it helps to ensure a consistent quality and product by multiple vendors to create a reliable platform for developers. That's a good thing. So for us, this conformance test was written from a contract project with the help of the SYCL working group. And this year, Stream HPC has helped us to complete and release this conformance. And you can actually access it on the website. Okay. Now, so to enable companies to test their products for conformance, Kronos basically has to establish an adopters program for each standard. Now, all the adopters sign this adopters agreement, pay a one-time fee for that particular version of the API. A company doesn't have to be a member of Kronos, as it turns out, to become an adopter. You can become an adopter of Kronos standard, and that will give you access to the conformance testing process. What that means is now you can download the source, you can access the adopters mailing list. You can upload the generated test results for the working group to approve. You can now submit an unlimited number of products for that version of standard. And once your implementation test results have been approved and your implementation is conformant, you can gain a fair bit of significant benefits. I'm actually learning this myself, actually, as it turns out. You can advertise the implementation as being conformant and use the API name and logo in association with its packaging and promotion. That's the marketing side. The other side actually is much more important, and that is that the implementation is covered by the Kronos intellectual property framework. What that means is that Kronos members literally grant you a license to use essential patents that they own and that you use in your implementation. That's actually pretty significant. Okay, so why am I going in this direction? Well, just like Simon, he's inspired me to do a count of SYCL's growth. He does it from the academic side. I'd like to do it from the engineering development side. So on SYCL.tech, a website that Rod here takes care of, actually initiated, you can see a listing of SYCL projects which has been growing steadily since 2012 and accelerated in the last 6 years, covering all areas, all areas. And every year I report this graph, and this year it's at 179. That's an incredible growth from 3 in 2012. I also look at the SYCL momentum on the open source projects. It's been huge on all fronts in the last 8 years, but especially in the last 3. Here I'm comparing the growth in open source implementations between the last SYCLCON and this one, just like what Simon is doing. And this is a chart of the many open source public GitHub projects showing the growth of Intel's Clang LLVM port in red, HipSYCL in blue. Yeah, I know Intel should be in blue, but that's just the way this thing comes out. Tricycle in yellow, Celerity in pink, and SYCL GTX, which is in green, but Peter Zuzak now actually works CodePlay, so it's probably dormant now. Paul Kear's Motorcycle in brown, and Inteon's PolyGuiSYCL in orange. Now, just look at the last year alone, we can see Intel's LLVM and HipSYCL has really accelerated. So I also look at the number of Stack Overflow questions. You know, measuring the popularity of the language is difficult, and you have to just sort of take like data points here and there. And what I do is I look at questions combining both SYCL and one API, because you know the two of them are in some ways kind of kind of linked. And from when I started on this back in 2016, I came from OpenMP to SYCL. When there were about 14 to now over 500 questions this year after 8 years, it's roughly a 500 times growth. It dipped a bit last year because there was the one API kickoff excitement, and usually there's a bit of leveling off, and that's okay. The number of people attending the SYCL working group has now doubled, tripled to over 20 people, more than 20 people per week, almost 30 people. Thanks to contribution from an absolutely insanely talented group of dedicated people across many companies, some of which you're going to hear in this conference talking about SYCL features, projects, and research. I'm absolutely grateful for all the help that I'm getting at building this SYCL momentum. I myself is not alone in this. And they are also the nicest bunch, I have to say, that I work with across my several decades of career in working in different consortiums and standards organizations. No, I don't say that at every. So SYCL is now definitely mainstream and growing rapidly. This is our time. Its success is based on open source and open standards and supporting both open and proprietary implementations. But an open source standard without a community, I claim, is useless. So we have a conformance. And the reason it's important is because it allows companies to play in the Khronos ecosystem without revealing their IP. But we also strongly support open source. So many of our developing features are on public GitHub. We did that deliberately so that the public now has a say in the development of those features, as well as the fixing of many of those defects. So that's when I'm going to jump into the second part of this talk, highlighting the growth of the last 12 months. First of all, our SYCL editor-in-chief, Renan Carriel, over there in red, who is effectively kind of like my co-chair since I took over SYCL 7 years ago, is proud to announce the release of SYCL 2020 version 7 with many small updates and clarifications. Now, don't get too excited. We do this every year because, we try to mark specific times of the year to release the new update of SYCL. This is about the right thing. It's not going to have any new features. That's not going to come until SYCL next. The most notable ones are in red. All right. So some of the features we have been working on in open GitHubs are in talks this week. Most of these have publicly accessible GitHubs. You have things about processor in memory packages, extensions, integrating MD-span, generalized dimensions, the one API number, DPPY, user-driven kernel fusion, clarifying the address spacing rules, SYCL design philosophy, the USM buffer interop, and the host task interop. And then there's also going to be talks about memory models, forward progress, and context. So to build a thriving community, we have to expand our ecosystem. And within Khronos, we can fund special projects. Now, one that we completed this year is the SYCL Conformance Test Project, otherwise known as CTS. That's done by Stream HPC. And now it's ready to be used by anyone who wants to be named as an official SYCL adopter. Now, the first year will probably be a little bit beta-ish, but that's okay. A second project is in line, will be announced soon, or it may already be announced. I don't know, Tim, but Tim knows the exact time. It's about building an online searchable SYCL reference, exactly like CPP reference. This is like an encyclopedia of SYCL with crosslinks that is much more usable than a SYCL specification. The RFP, once released, is going to be open to Chronos and non-Chronos entities, and we'll start with basic information to help SYCL developers anywhere. So you can literally type SYCL buffer accessor to Google or any search engine, and it would guide you immediately to useful information. In future, we may even be able to offer example codes that you can run, compile, just like the way CPP reference have today. This will make it very easy to analyze code, compare implementation, or file bug reports. Maybe one day it will be like ChatGPT. It just answers your question directly and writes your code, maybe. Okay, so we can look forward maybe to something like that. So a very exciting development in the ecosystem is putting SYCL on Compiler Explorer. Compiler Explorer is a web-based compilation system maintained by Nevin's good friend, Matt Godbolt in Chicago. And since inception, now maintains hundreds of compiler versions for C and C++ alone, and many other languages. If you're a compiler developer or user, you are probably well familiar with this because you can play with the code, test whether it compiles, and in some cases run or just generate the IR to see how optimized it is. Now, compilers, writers love this. And when I was a compiler writer, I used it every day. To compare code generation with others. The users use it to file bug reports. It also hosts a number of Chronos languages. Right now, just OpenCL, and now it has SYCL. Now, the SYCL is actually hiding under the C++ tag. That's okay, not great, but at least it's there. You can use this link. You just type it in, and this address, you're going to get this exact output, which actually runs SYCL using a DP++ branch of the compiler. But because Compiler Explorer doesn't know GPUs yet, he wants us to help him work with that. This actually defaults to the CPU in this computation. Now, as Chris Gearing said, from Mobileye said, when I showed this, we love working with this. And he said, I love his quote. He says, Compiler Explorer is more fun than work. I absolutely agree. So you can also generate IR, and all this is under the C++ tag, showing how similar this is to C++. In the future, I'm hoping to launch a project to enable more features like having SYCL under its own SYCL tag, and then under that SYCL tag, we can now add all three compiler implementations and different versions of it. You see how useful that can be? You can literally compare version to version within a single compiler. And then maybe we can help Matt Godbolt provision it with GPUs so that it can truly be compiling using the GPU code and having all three of, and then generating true SPIR-V. Right now you can't see it, but this is not really true SPIR-V, even though it's got the triple, and it looks like a little bit like SPIR-V. It's some sort of bastardized LLVM. All right. Did it jump? No. Okay, so continuing. So just like SYCL, because it is open, I want to talk a little bit about RISC-V. RISC-V is growing as a free and open RISC instruction set architecture. There's no license required, but the engineering can be open or closed. Now, like SYCL, it's a very collaborative approach across the community. This is very simple ISA, about 40 instructions, with multiple optional extensions. I call it the Lego block of ISA. Basically, you can put a Lego block of different ISA combinations together. Every implementation can be different clock speeds, how it processes instructions, or the number of hardware threads. This makes it a very flexible system. I've been chairing the data center cloud computing SIG, as well as working in the high performance computing SIG, the machine learning AI SIG, and the autonomous vehicle SIG. And RISC-V has been primarily thought of as CPUs and microcontrollers, but I think it can also shine for RISC-V to be used as an accelerator. In fact, I think it's better used as an accelerator for things like NPUs, like Bluefield, SATA, crypto, or network accelerators, or even a full-fledged accelerated compute unit, graphics or AI. There are actually many companies already working in this direction. So I'm trying to start an accelerator SIG that deal with the issues of using RISC-V as an accelerator. Now, along with trying to influence RISC-V towards accelerators and having them use SYCL, we actually have obtained 2 EU multi-million-dollar projects combining SYCL on RISC-V on data center and cloud computing. Now, one is called Cyclops, and the other is called Arrow. The vision of Cyclops project is basically to enable a better solutions for AI and data mining for extremely large and diverse data by democratizing AI acceleration using open standards and enabling a healthy competitiveness, and that's the marketing byline. what they're trying to do is they want to, the vision is essentially just the standardization and the adoption of RISC-V, the open instruction set architecture for AI and analytics as acceleration, and the emergence and growth of SYCL as an open cross-architecture programming model for all of this, and ultimately to leverage CERN's Clang, which is essentially a C++ interpreter, and convert into a SYCL interpreter. That's amazing that's coming there. Next. Arrow has a single mission of enabling the future of heterogeneous EU cloud infrastructure. And from our point of view, Arrow will develop the ecosystem surrounding standardized open source heterogeneous programming languages and runtime, basically SYCL, OpenCL, DPC++, OneAPI for the heterogeneous EU cloud. And then you can also see the member companies of these major EU projects. Uwe here, I think he's here, is working on a lot of these projects, both of these projects. Now, you've seen this slide before. I move a little bit. The slide is about the parallel industry initiative. Simon mentioned the importance of ISO C++. We all recognize the importance of that, and we pattern ourselves following the every 3-year delivery of ISO C++ since C++ 11. And the only thing I really moved is, of course, SYCL's 2020 was based on C++ 17. We now know that's our next SYCL. We don't know when that will be. It will likely be either be based on C++ 20 or 23. An argument could be sufficiently made for either of these, depending on some pretty intricate details about MD span and subscript operators. For that, I invite you to bug Nevin during the break. I'm trying to keep some secrets. All right. You'll see here are the 3 main industrial commercial implementations of Intel, CodePlay, and HIPSYCL. I want to call out some new changes, like the fact that HIPSYCL branch for Intel is now not experimental. And indeed, I just watched Axel at the hackathon yesterday, 2 days ago, successfully compile HIPSYCL on Ponte Vecchio. That's absolutely amazing. Thank you. Now, Axel is also planning to change the name of his compiler. For that, I think you should listen to his talk and find out how you can contribute to that. So just like a great Major League Baseball team, we also have a great farm team of experimental branches showing how easy it is to build a SYCL implementation for some pretty unique custom processors. Some of these are by students like SYCLCON. Some of these are by scientists like Celerity, or by educators like Paul Kier's Motorcycle. So the new contribution this year is the processor in memory work from Samsung. So this is what we recommend as a migration path. Many people ask, if you're starting from scratch and only ever use CPU with no GPU software, then just start with SYCL. There's no lock-in. It's pretty easy to learn. If you're starting from C++, it's really easy to use SYCL on top of C++. If you're starting from CUDA, port. There's many porting programs. There's like Cyclomatic, or I can't remember the exact name of it. The Intel people, there's a talk that's going to talk about that. You might want to maintain both versions. I don't know. And if you're starting from another language, SPIR-V essentially enables you to get that going pretty quickly. All right, my last bit, the ecosystem and the future growth directions. So I do this slide also every year, but so that you get familiar with it. So this is the latest news on SYCL. From CodePlay CTO, Ruben Reyes, SYCL performance for NVIDIA and AMD GPUs matches native system language, and developers can write SYCL code and use OneAPI to target NVIDIA and AMD GPUs with binary. Go to SYCL.tech to read all about that. There's a news that GROMACS 2023 is released with better SYCL for Intel, AMD, NVIDIA, and STFC, the UK Science Council, I don't remember all the acronyms meaning, but that's essentially what it means, basically plans to accelerate exascale software in CFDs and code coupling using SYCL. And of course, another article talking about running OneAPI C++ with SYCL on Intel Arc and Iris Xe GPUs. And then at the bottom, you can see the working group and those attending. We recently have much more attendance from Stream HPC, Qualcomm, Mobileye, Samsung, and Huawei. So finally, I want to talk about OneAPI and SYCL. We're working together to bring developers an open standard environment. OneAPI basically provides developers with a platform to build accelerated software, and SYCL sits at the heart of OneAPI, providing a mature, open standard interface for developers under the language domain. And there are other special interest groups for AI, math, and hardware with their own open source specifications to match them, to back them up. When you write code using the One API platform, you will be using the SYCL interface to interact with the low-level hardware on your machine. Whether that is targeting Intel GPUs, NVIDIA GPUs, or AMD GPUs, we're driving the future programming for heterogeneous architecture. And you can join the community by joining One API, either as chairs or experts to vote on the future. For that, contact Rod. The strategy, the national labs in the United States is to focus on enabling developers with a standard programming environment so that the software they write can be deployed across multiple supercomputers that bring pre-exascale to exascale computing to researchers. Now, I understand that the ECP program, the exascale computing project, is coming to an end. I'm hoping that it will be replaced by the zettascale computing project, which is the next 10 to the 3 more flops. So we have built partnership with Lawrence Berkeley National Lab, Argonne National Lab, and Oak Ridge National Lab to enable SYCL on their next generation of supercomputers. You can see a small snapshot of some of the frameworks and software that is enabled by using SYCL open standard, from LAMP-PS, which is a particle simulator, to Eigen, a linear algebra library used by TensorFlow framework for tensor operations. But I want more. I want much more workload have to be SYCL ready. And some of this is provided in the UK HPC workload, thanks to Tobias Weinzierl. I don't think he's here. And on Archer 2, which is on the right, the list, and others in the Durham and in the joint undertaking, in the black down here. I don't know if, I haven't had time to check if they're all C++, some of them are not. But when I was working on the Coral 2 procurement, when I was still at IBM, we had this list of other C++ workload that we also need to carry. And it would be great if we can get SYCL ready, to make them SYCL ready, not just ready, but also make them performant as well. Okay, so SYCL is a universal programming language for HPC. In 2019, in June, the Euro HPC Joint Undertaking Government Board basically selected 8 sites for supercomputing centers located in 8 different EU member states. And SYCL through HIPSYCL is now basically in Leonardo in Italy, Lumi in Finland, and Carolina in the Czech Republic. And 2 of these, Lumi and Leonardo, are Europe's first pre-exascale machines. So SYCL has a long pedigree in machine learning, and recent implementation shows its use in the RISC-V vector extension that we have for kernel compilation flow using forward convolution. Huawei uses it for their Ascend AI chipset for MLIR and TVM. Historically, CodePlay has converted SYCL on TensorFlow, Eigen, and Vision CPP, implemented low-level convolution operations like Winograd in SYCL BLAST, SYCL DNN, and SYCL ML. And more recently, the work had extended to 1MKL. Now, I envision a need for a future technical study group under SYCL for ML, just like Vulkan has a Vulkan ML TSG. I want a SYCL ML TSG. In the meantime, get a taste of it from Dylan Angus, Marcel Breyer, and Chris Gearing's talk, and the coming machine learning panel. So here's a little bit of talk about the safety critical aspect. Chronos experience with safety critical graphics APIs goes back to 2003 with OpenGL SC 1.0 that defined a minimal subset of OpenGL ES 1.0 in 2005 for easier certification in the DO 178B standard for avionics displays. Now, when OpenGL ES 2.0 introduced programmable shaders, OpenGL SC 2.0 integrated that functionality in 2016 for ISO 26262, a standard that I also work in, which is now becoming ISO 21448, so that it can be ready for machine learning and safety in autonomous vehicles for automotive displays. And now, as the need for safety certified embedded GPU graphics and compute expands into many new market areas, Chronos is defining a safety critical subset of Vulkan to create Vulkan SC. And Vulkan is a very compelling starting point for a safety critical standard because it is ready. It is already a thin, lightweight API, and Vulkan SC will further reduce the driver size and strengthen the API. error handling using the MISRA compliance. Now we're expecting SC to be released, and I think it already has. So the big news is, and I want you to go to Eric's talk, where we're going to talk about the new SYCL SC working group led by Core AVI and CoPlay, gathering industry academic requirements following the same ideal of reduced API surface area that can be much more deterministic. So I want to call out Eric's talk and Leonidas' talk. I don't know if he's here. Yes, Leonidas, there you are. Thank God, we finally meet. We missed each other at RISC-V last year on safety critical and high performance critical systems. I'm getting down to my last two slides, so. All right, so I'm also chairing the AutoSAR liaison in Kronos, which have already started a Kronos AutoSAR meetings every year, and that's going to result in a SYCL demonstrator. It's proposed to introduce AutoSAR standard API, which will regulate feature set and particular ways of working with it. The proposed approach basically offers a highly flexible for vendors to provide what AutoSAR calls an adaptive platform. This is their platform that uses parallelism, whereas the original classic platform doesn't use any parallelism. They didn't need that in older cars, depending on the customer hardware. So at the same time, AutoSAR Consortium can use this SYCL demonstrator to ensure safe and effective the effectiveness of the chosen feature set. Final words. SYCL can be a part of a standard programming model, but the programming model must persist. But it also has to be high quality and portable with conformance tests. We launched SYCL 2020 in 2021, and we've been building this insane SYCL momentum. SYCL absolutely is mainstream. The market needs SYCL to evolve with more workloads. SYCL's thriving community, I dare say, is our biggest, most important asset today. The future of SYCL is important on emerging transformative technologies. It can be part of a standard programming model for all HPC, embedded, AI, ML, and automotive. And we're forging ahead with directions in Europe and Asia. This is a slide that shows a bunch of important links. I want to call out that there's an advisory panel that's regularly chaired by Tom Deacon in the back here. That's going to happen next week, Tuesday, April 25th, 2023 at 4 p.m. UK. That's a great way to join without exchanging money, without signing anything other than an NDA. And then finally, please enjoy the conference. I was going to call all the talks that are SYCL related, but it seems I don't need to. Just looking at most of the program, it seems to be a lot of it there. And you're going to see something you like on SYCL and OpenCL for everyone. But especially I want to call out the pre-conference activity that I attended. I wanted to sample them to see how they go. The SYCL hackathon was incredible. It gives you a chance to try out the performance of your code. This is where Axel tested HipSYCL on new Intel clusters. We also had not one, but two tutorials, one for beginners and another for best practices. And I want to encourage that to continue in the future. We're going to be at ISC with a SYCL BOF and tutorial. We're going to be at SC with a SYCL BOF tutorial and maybe a workshop. So please look for us there. SYCL is mainstream. Thank you.